All right. Good morning, everyone. Hey, Alejandro.
Hey, how are you, Sandro? How are you doing?
Doing well. Doing
Yeah,
well.
okay. Okay, good.
Yeah.
Looks
Nice
like we
seeing
have
you.
some people connecting now. That's good. We have
Yeah.
some
Yeah.
audience today.
Yeah.
It's a very
Let me
interesting
know
topic,
if.
actually.
Yeah. Let me know if you see other people there waiting to join. I'll admit
Yep.
him. Um, but anyways, welcome everyone to a new session of Festo Connect and Learn. We are your
Nice
usual
to have it.
host. Yeah, we're your usual host, Alejandro there from Canada, sitting in Toronto, and myself, Sandro, here sitting in Chicago. I'm currently sitting in the Chicago office, in the Festo office, and you can see there the other camera that I have here. Here you can see it, right? So I have that other camera where we're going to be showing some hardware. We're also going to be covering some software as well, and I'm pretty sure that most of you guys are going to enjoy this, especially if you've done programming before and if you have dealt with multiple PLC brands. You're definitely going to see the benefit of this. So
Even from the mechanical point of view as well.
definitely, definitely.
Yeah.
This is really this really is really good. The relationship between a previous session that we had, which was about Mr. Gantry. I don't know if you missed it probably or not, but it's in YouTube as well. I'll show it here. But anyways, let's start with our usual introduction here. Let me share my screen here so you can see it. So this is the invitation that you probably saw somewhere, and that's why you joined today. And today we're going to be talking about simple control of a mechatronic system in Rockwell or Siemens. We didn't have enough space to add more brands here, but really it can be more brands. Alejandro,
Yeah.
I think you have more examples about what other brands we can cover as well here.
Yeah, for sure. Yeah, we definitely cover more brands. We're going to talk about that later on, but yeah, we definitely have more logos to put in here.
Right. Okay. Perfect. And we usually do these sessions every other week. Apparently, it seems like maybe the next session is going to be until November. But bear with us. If you missed a previous episode, you can watch it on YouTube.
Yeah.
Usually, this takes 30 minutes, 31, 32 minutes, depending on the questions. And one big reminder, and this is probably the most important part of this session, is this is for you guys. You can ask any questions. You can
Yeah.
unmute yourself.
Full
This is not a
interaction.
Yes, this is not a presentation from us just talking and talking. This is for you. Feel free to unmute, or you can also put it on the chat and we'll address the questions, okay? Or
Yeah.
suggestions or comments.
Yeah, important.
Yeah. The other thing that I wanted to show here is you can always, if you don't remember or you cannot think about a question that you have right now, you can always reach out to us on our email addresses if you have any other questions, okay? So with that, let's take a look at what we're going to be doing today, right? So Alejandro, let me show you here.
Yeah,
This is
before you
yeah.
jump in, Sandro, one important thing here is remember that we speak your language. So French, Spanish, and English are always welcome. Again, if you have any question, you can type it in your comments later on YouTube channel, Festo Canada, Festo US. Our playlist is there, so you can always reach us there. And if you have any other question, you can always type an email or something like that.
Okay, so what I'm going to show you now is this is a web visualization that I have open on Google Chrome, right? So this is just your browser, Google Chrome. It could be Microsoft Edge or whatever. I opened this web visualization, and from here I can see the status of those systems that I have on the camera, and I'm going to show you that in just a second. So I can see what's the actual position. I can see the current movements. I can see several things, right? We're going to go into the details here shortly. One key thing that I wanted to mention at this point is notice here on the bottom right, I have a selector that says Profinet or Ethernet IP, right? Right now, I have it selected as Ethernet IP, and I'm going to show you why in just a second. So I'm going to stop sharing. Yeah, I'm going to stop sharing here for another second, and I'm going to spotlight this other camera so I can show you what this is about. So I'm going to walk over here, and you can still see me here, right? Okay. So what I have here is I have three different systems. So these are three different kinematic systems. I have X, Y, Z, so there's an X-axis, Y-axis, and then a Z-axis. I have another X, Y, Z here, so X, Y, and Z. And then over here, I have just an X and Y, so just a little gantry that just does X and Y movements. So if you think about it, here I have three servo motors. Here I'm using actually three stepper drives, which are with closed loop, so they have encoder, so that's 3 and 3. And then over here, I have 2, so that's 5 and 3, right? So that's a total of 8 servo drives being controlled concurrently, right? And you remember that little switch that I showed you on the web visualization? That is to toggle between what am I going to be controlling it with, right? So I don't know if you noticed, but here I have a tiny PLC from Siemens. This is an S7-1200. It's a
very basic PLC, actually.
Very basic PLC. I just have 24 volts here feeding the PLC for power supply, and then I just have an Ethernet cable here, which is for Profinet communication, right? And then over here, I have a Rockwell PLC. Actually, I have 2, but I'm just using 1. And this is an L16ER, so it's a CompactLogix, and it's one of the most basic ones from the CompactLogix line. And these are connected together on the same network. If you know about controls just a little bit, you know that Siemens, they use Profinet mostly, and Rockwell use Ethernet IP, right? So the big question is always, well, I'm working on this project today with Rockwell, but tomorrow I'm working with a Siemens PLC. How do I deal with the interaction, right? So we simplified that. And I'm going to show you what happens here. So just by pressing this button, I'm going to start the movement on all of the axes at the same time. And this is not just a point-to-point movement. I'm actually doing interpolation operations here. So here I'm drawing a star. Here I'm simulating dispensing like a puzzle piece. And then here I'm just doing some circles. I'm going to grab the camera and show you here shortly, but that's basically what we're doing here. We're going to go into why is this a nice thing to have in just a second. But anyways, any questions? Alejandro, please pause me because I tend to talk a lot.
You're going by yourself, huh?
Right.
No, you were talking about brands. So we're mentioning Rockwell, Siemens because they are the vast in the market for communication protocols, Ethernet IP and Profinet, but you can also use Omron, Beckhoff, or any other in the market that talks on those 2 protocols. So that's important, is a key actually point, because not all the controllers use both at the same time. So for example, our controller in this case is running on the same connection 2 protocols, Ethernet IP and Profinet. So you normally have to have an additional card and things like that to communicate with different protocols. This is acting as a gateway with multi-protocol. So
exactly. So what I'm gonna be showing now is I'm just gonna grab this camera so I can show you what this is about. I'm gonna start this process again with this button. So now you can see that I have a pen there as a tool, and I'm doing a star, right? So I'm executing a CNC code, and I'm doing a star. Over here, I'm executing like a puzzle, and this is simulating like a dispensing head, right? So I could be dispensing glue or some other thing. And I'm gonna start it again so you can see. And here, I'm just doing a circle. So this could be simulating
something important here also is, Sandro, we're running advanced kinematics and not necessarily only like X, Y, Z or Z. In this case, for example, the gantry on the right side is a 2 motors fully interpolated with a 1 belt connected to. So that is an H gantry, which is called advanced kinematics. Some people use T gantries or HT or HBOTs. So all those are combined with the rest of the kinematic, which is like X, Y, Z or X, Y only.
Exactly.
Or even individual axes. Let's get into the details now that we saw like what to expect. And then people will look into that and maybe they have some questions later on.
Right. So if we're talking about details, and maybe for the programmers on the session today live, you're probably gonna appreciate this a little bit more. So I'm going to open here my program so you can see what this is about. I'm running. Oh no, this is Rockwell. I showed you Siemens right now. I'm controlling with Profinet, right? So in Siemens, what I have is I'm just gonna open this programming block here, and I'm gonna open this other thing. So I'm using a function block that has all of the parameters that I need to control these 3 different kinematics. The first time that I saw this function block, I was like, this is amazing because I have everything here and I can easily toggle a movement. So I'm going to show you here. This is the function block in the TIA portal software. So here, what I'm doing is I'm just basically by using this. I'm gonna make it live or online. Go online. So basically here, you see this K1, for example. So K1, it's kinematics 1. So that would be the kinematics on the far left, right? And then if I keep scrolling down, and then I have K2, which is kinematics 2, the one on the far right. And then kinematics 3 is the one in the middle. That's the way that I have them arranged. But if we look at what's available here in this function block, you're going to see that I have a mode selector. And this mode selector is just basically to tell the system if I want to move jogging, if I want to move point to point, or if I want to move like I'm doing it now, if I want to move doing a CNC operation. The CNC operation is really cool because the way that you do this is you just grab a DXF file. You grab the DXF file, you import the DXF file, and then that is translated to G-code. You don't have to do a lot of things. You actually just translate to G-code, and then you can just execute that CNC code, and you can do whatever you want. That's included in that CNC code. It will automatically interpolate the axis. So that's pretty cool.
Let's talk about the modes, Sandro. That is important to understand, like what that means. So you can imagine if you have a gantry or a dispensing head or something that is doing some sort of pick and place, you can select different type of modes for that particular gantry. So for example, kinematics 1 or 2 or 3. And then here, the motion functionality will determine what the gantry will do. So for instance, what Sandro is running right now is a dispensing. So you have particular functions like M and H, for example, to trigger nozzles and dispense product, or you can switch to point where you want to move only one axis at a time. Or we have a nice functionality, which I like it a lot, especially for collision. It's called Safe Move. The Safe Move is a pre-programmed U-shape for gantry systems that will automatically clear a particular values that we have in the function block that can be always configured, and then that will allow us to avoid any collision point. For example, if you're putting a bottle of shampoo in a box and you want to clear out, you don't have to program all those points. You can just basically tell where you want to go after, and then it will automatically calculate all the path with some particular parameters that we have in the function block.
Right.
So, and the other thing nice about it is the jog functionality, where you can just go and start jogging the axis right away, and that will be a nice tool for example, HMI or teach pendants and things like that.
And I'm going to give away a little secret here. Well, it's technically not a secret, but you remember that at the very beginning I mentioned that this has a lot to do. Oh, look how young I looked in that image. It's been a while since we did this.
This is the pandemic. Don't
right. This is the pandemic look. If you saw this session that we did back in August, I believe, or something like that, this is what we were using to control this huge gantry. Exactly this same function block. And Alejandro, this is what he was using for jogging. This is what he was using for point-to-point moves. So from the control standpoint, it's really great. It's really easy to use. I'm going to show you an example on how easy this is to use. So for example, if I go into TIA portal and I show you a sequence on how this looks like, this is just, these lines are just doing my homing. So in just a few lines, I think starting from here, so around here.
That is not really complicated.
It's just a few lines for me to do that, to execute that CNC operation. It's really easy. In the past, you will have to program a lot of steps, move to this point, move to this other point, and so on. With this, is greatly simplified, right?
Yeah, definitely.
So now, I just show you the Siemens functionality, and maybe at this point you were like, yeah, I'm not really interested in Siemens. I'm a Rockwell user, right? So, okay, it's as easy as this. I'm just gonna open Studio 5000. I'm here already. I'm just gonna go to my visualization, and I'm just gonna toggle the switch. Toggle the switch, and now I'm operating over Ethernet IP. How can I...
With 3 kinematics, which is nice.
With 3 kinematics, right. So how can I confirm this? Well, I'm going to go into my main routine, and then I'm going to execute this. I'm going to toggle this bit. And now you see the kinematics moving as well. Same program. Well, actually, I have a different program on the left. I'm running a pick and place operation. But it's the same kinematics. So imagine the beauty of this, and especially if you're a machine builder. Imagine the beauty. You can standardize on your mechanics, and it doesn't matter if your end user needs one one brand of PLC or the other one, you can still keep your mechanics. You don't have to be dealing with, oh, now I got to change the bill of materials. I got to change all of that, right?
Yeah, that's
But
important.
Alejandro, for the sake of the discussion here, let's pause for just 30 seconds so we can see if there are any questions or if anyone has any comments.
Yeah,
Or maybe someone is like, I don't know, this doesn't look very cool. So, guys that are on the call, do you have any comments, any suggestions,
maybe
anything that
experiences using different
experiences?
brands.
Yeah, I see some people on the call.
Yeah,
So,
and at the same time, Sandra, at the same time, I would like to also point it out that some of the additional features we have, we're not showing it here, but for example, IO-Link extension, we have that as part of the function block. So we can extend the end-of-arm tooling through the AOI or through the function block from Siemens and extend additional IOs that can go directly tied into that function block. So imagine if you have multiple machines and every function block will control portion of the machine, then you can reproduce code very easily. So that's
right.
a good feature on it. We also have some standardization on controls like the cabinets and boxes to control all this. So we call that the FMCP, the Festo Motion Control Package. And it's also tied into the mechanics, which is nice. We have handling guide online, we have the function blocks, and we also have the mechanical boxes for it.
Right.
So you
And
want
it
to talk
looks,
about that, or
yeah, sure.
so far no questions, so I think we can keep going.
Okay, so what Alejandro is referring to, it looks something like this. Actually, I right now in my office, I don't have such a box set up, right? Like I have all of the components on the floor and the cables and everything, but this is not an industrial environment, of course. This is just an office, right? But if you were to have this in industrial environment, what we can supply, what we can actually what we do with customers is we provide this control panel, and this control panel already has all of the elements in there to drive the different kinematics that you would be using. In
Yeah, the
this
idea is
particular
simplification. Yeah.
Right. In this particular picture, for example, we're just showing here on the right, we're showing three servo drives, right? And meaning that I could drive just one kinematic if I wanted to. You don't have, and I gotta be really clear about this. You don't have to drive three kinematics like I'm doing now. You can drive just one kinematic or two kinematics, right? Or
Yeah,
whatever,
I also
three.
wanted to mention that too. Yeah, that's important. Let's chat
Yeah.
about that because that's important. And also the virtualization of this system, Sandro. You want
Yes.
to talk about
Yes.
that?
That's a good point. So let me. Can you also talk about the other features that you have on on those
Yes.
slides?
Let's chat about the virtualization first. So imagine if you have a gantry that you ordered online through the handling guide online, and eventually you want to have your programmers starting to do coding, and they have the cabinet and everything else. How they can start working on the coding and simulating all the axes without having the mechanics. So the good thing about this is we can configure the Festo motion control box in a virtual environment. That means you're going to be controlling the servos like a virtual. So you can still code in Alan Bradley, code in Siemens or Omron or any other, and you can send commands through the protocols and everything else, move the axis in a virtual, and as soon as you get the mechanics, then you can switch them to be real. And that is a good benefit because now you're not waiting for mechanics to arrive in order to open the laptop and start programming. That's one thing. The other thing about that is about virtualization is you get a gantry, a real gantry, but you also have two more that can be virtual. So in this case, you can switch any of those mechanics there to be virtual and run the other ones on real. That's also an advantage because now you can expand the system as you grow. So
Right.
are you going to show any of the virtuals now or no?
Yeah, I'm gonna show that. I just wanted to grab this button that I have on the
Oh,
other
okay.
side of the room.
Okay.
So yeah, I'm gonna show that now. Let me just open this other thing that I have
Yep.
here. But that is a really great point, and I actually showed this to a customer recently, the virtualization that Alejandro was talking about, and he was really pleasantly surprised because he was like, you know what, this is great because the guys are not done yet assembling the mechanics, but I can already test my code and I can see if the system is going to move as it was designed to move, right? So I'm going to show you that here. So let me share my screen again. So what Alejandro is referring to is Actually, I can't. You can see my screen again, right?
Yeah, you
So
can switch
what?
between the gantries.
Yeah. So what Alejandro is referring to is that right now I switched to Profinet again, and then remember I have the little button here. So what I can do is I can press this button, and then the systems will run. Right now I still have them running, not virtually, but running physically.
The realm. Hmm.
Yeah, but it will look something like this. So now, if you don't have the system, the physical system connected, you can see here what's going on, right? So I
On the
can
web
see,
browser.
yes, on a web browser. And this is not a special software. This is not something that you have to purchase a license for. It's
Hmm.
just a browser that you can download from the internet. So now, as you can see here, I can see what each system is doing. So right now I'm looking at the one on the far left on my computer. I'm gonna switch to the
You can
one
switch to
on
the
the
next one.
middle, right?
Hmm.
The one on the middle is this one. So I'm gonna execute that program again from my Siemens PLC. There, it's running, and now you can see that that
That's a
system is
different
moving.
path. Yeah.
It's a different path, definitely, right?
Hmm.
So now I can see it is moving. Here are the actual positions. Here is the actual speed, and I can see the overall status of the system here. So now it tells me I'm done, right? So I don't know if you noticed, but the change of status is here. But now it's telling me it's done. I'm gonna run that once again, but now I'm gonna switch to the other system, the one that's kind of like doing a circle. So I'm gonna press the button again. There it goes, and you can see
So
this.
something nice about that, also, Sandro, you can see the override slider on the left. So you can imagine you're running a gantry full speed. Let's say you don't want to go that fast, but the programmer configures something on the software that probably is too fast. You can get into the browser, get permissions into it, and now you can move that slider to reduce all the axes at the same time. So now you can switch from the web browser, you can switch to different gantries, you can switch between multiple protocols, and you can also reduce the override speed for everybody, as
Right.
well as seeing all the functionalities, all the information directly on the web browser. That is,
Exactly.
yeah.
Exactly. Yeah, I usually use this a lot, like a lot. When a customer sends me, so for example, if a customer says, "Hey, this is not working right," and I've had some cases where they send me an email at 11 p.m.
Hmm.
and he just says, "Hey, please help me. I mean, I'm stuck here." So I tell him I'm at home already, right? So he says, "Hey, please take a look." So what I can do is I can just grab his code, put it in here, put it in virtual mode, and I can run everything without
Hmm.
having to be right in front of the mechanics, right? Let me try something else
Yeah.
here and see if I can log
If
in.
there's any question, guys, you can type it in on the chat. You're more than welcome. We're always open to any technical question or commercial question. So,
Right. I'm also
Sandro, what are you
curious.
going to
Yeah.
show?
No, I was trying to open something else, but I can't find it right now. I'm
That's
also
okay.
curious to know what the guys think in regards to future sessions. We usually ask this question as well in
Yeah,
all of the
that's important.
sessions. What do you guys are interested in? Because maybe Alejandro and myself, we're coming up with these topics, and you're like, that's lame, that's boring, or something. And you want to know more about, I don't know, vision systems, or you want to know more about
Maybe
sensors.
different, yeah, different
There's multiple.
applications.
That's the beauty of
Yeah,
the automation world. There's
yeah, you can
multiple.
always chat it in the, you can always type it in the chat.
Yeah, exactly.
Okay.
So what else is there to show, Alejandro? I think we pretty
Yeah,
much cover everything that we wanted to show.
yeah, I think multi-kinematics is definitely a good advantage. Communication is also a good advantage. Also, actually, one point on the dispensing. Dispensing applications are very popular in the market, and you can get large gantries from Festo for dispensing applications, and you can control the nozzle, for example, directly from the function block. So you can imagine in the function block, you have some outputs. You see on the right-hand side, the outputs, there is something called the H point. H point is in gluing applications, means turn on or turn off the nozzle. So that means you can control directly the nozzle from the function block or from the G code. The other portion important is sometimes you have some time delay or latency between activating the nozzle and getting the response back. So important here is our controller will have a dedicated output for nozzle control, as well as Rockwell or Siemens to be broadcasted. So you can connect the nozzle either from your controller or directly from the Festo controller. controller. So that will take out that delay in response, because there's always like a 10 or 50 milliseconds in dispensing is quite a bit. So that is also a good benefit. Safety status on the function block is important. So we have a dedicated input for safety purposes. So if you trigger that, the system will automatically go into the safe mode, as well as the safe torque off that is part of the Festo motion control package. So we have a few other benefits. I mean, I think we want to touch base mainly on the multi-kinematics and communication, which I think is important. If you have any other protocol that you think it could be here, let's chat about OPC UA. So for example, Modbus TCP. Can we connect to Modbus TCP or OPC UA? Yes. Some people prefer OPC UA, so you can always send your commands. If you don't have a function block like this and your controller is using OPC UA, you can send the commands directly through that protocol. Some other people will say, well, can I develop my like Node.js or any other software in Python and control this? Yes, you can. You can use Modbus TCP, or you can use as well OPC UA. So we have some connectivities behind the standard industrial ones that are more popular, which is Ethernet IP and Profinet. Some people will say, can I use EtherCAT? Can I use maybe a gateway? Yeah, it's possible to do it as well.
Right.
Any other comment?
There is a comment there, a question by Zoom user. It says, "Hi, is that virtualization with just the PLC?" So the virtualization happens on the Festo motion controller. So you would have to have the like the Siemens PLC or the Rockwell PLC communicate over the Profinet or Ethernet IP to the Festo motion controller, and then the virtualization happens on that controller.
Yeah.
So
but also
for example,
important, but hold on, but important here is, can you virtualize the software that you are currently running without having the PLC? So that is important, because you can get, for example, if you tell me, hey, I'm gonna buy this, I need to get this hardware, can I start playing around? Yes, you can virtualize the controller itself to be in full virtual in your computer. Of course, you don't have connectivity extra outside, but you can still run code inside. So that's part also of the virtualization.
Right.
You want to show something else?
Yeah, I was gonna show. Just give me a second here. I was gonna show that I just switched to virtual mode right now.
Okay.
So we have 3 minutes left, so I think this is good enough to show. So I don't know if you saw this axis. Hold on. This axis right here started doing home. Let me replay that because I did it while you were talking. Sorry.
Yeah, go ahead. Any other question, guys? So far, I think we have covered the majority of the topic. We're almost at the end. We're not gonna take too long. Anyways, in case you have any other questions later on, you can always connect with us. This session is always 30 minutes. It's really to open up the topic, get into basic details. But if you want to get more deep, please go ahead. Ask your questions. Go ahead, Sandro. You have.
And by the way, Zoom user, did that answer your question? I think we tried, both Alejandro and myself, but I just want to make sure if you can type it in there. Just want to make sure that was cleared also.
Yeah. What are you going to show now?
So I'm going to show. Hold on. I have an error here. There we go. Okay, so I'm going to show just the homing process here. So you see the kinematics on the far left. I'm going to toggle right now the button, so it should home. I want you to see this. So I toggle the button, and you see on the screen, it's moving, but the physical kinematics is not moving. Because what
you want to spotlight the video, Sandro?
Oh,
the video
sorry. Yes. Let me do that.
Yeah, spotlight so we can see it. It's pretty far.
Okay, spotlight this video. There we go. So I'm gonna stop sharing my screen so you can actually see the video bigger.
Yep, there you go.
Do you see the two systems on the right moving? They are moving, right? And the one on the left is not moving, right?
Yeah.
The one on the left.
Switch to the virtual one.
Yes, the one on the left is not moving because it's not moving in the real world. It is moving virtually. So here, I'm showing my screen again. So I'm gonna start the system again. There it goes. The two systems on the right are moving. The one on the left is not physically moving, but look at the web browser. It is moving. So it is currently working as a virtual system, right? That's what we meant earlier by working in virtual mode. So I hope you get that message, because to me, this is also one of my favorite features. Anyways, we are out of time. As I mentioned earlier, our next session is probably going to be November, let me see. It's probably going to be November the 5th or maybe October 29th. But yeah, let's keep in touch on LinkedIn. If you have any questions, feel free to type them
or
in
share the videos too.
or share the videos. Remember that we also have these playlists. So on YouTube, on Festo US and Festo Canada as well. So if you missed any portion of the videos, you can always go back and watch them. And the other thing is, in half an hour, we're starting the same session, but in Spanish.
En
so
español.
if you prefer Spanish or Español, we're going to be doing it in Spanish as well. So again, thank you everyone for joining, and we really hope that you enjoy the content. All right, let me see. There's one comment on the chat.
No, thank you. Thanks for everybody. Thanks to everybody like joining the call. Thanks for having us here. I hope you guys enjoy, and yeah, connect with us, and we will share more topics later on. Sandro, thank you so much.
Hey, Jimmy, there he is, the man again. Yeah, thank you all, guys. We'll be talking.
We're gonna see anybody interested on the Spanish session en algunos minutos. ¿Listo? Ahorita nos vemos.
Ahorita nos vemos. Chao.
Okay, chao. Bye.